Okay, so these are the last two examples I have for U-substitution. Let's give you some time, pause and take a look at some different possibilities for U. And until you get used to this, you should probably actually go through and try a couple things. Say maybe U equals cosine x and then see how that pans out for you, or U equals sine x and see how that pans out for you, U equals e to the sine x. Try a bunch of different things until you start to get good at what is the best choice for you. All right, pause if you want to try it yourself first, and now I'm going to give you the answer. All right, bottom line, what you want to observe is that you have a formula for e to the u. Okay, maybe that was enough to get you started, and you can, again, try it. So that means if we're going to later be integrating e to the u, that forces our u to be sine x, and then our du is going to be cosine x dx. Again, make sure you remember you're finding a derivative when you're finding du. Okay, so let's use some color coding here. Cosine x dx is in the problem, so that's going to become a du. And then this part is just e to the u. Now again, this is a definite integral, so I want to be careful of the bounds. I personally am going to change the bounds, or you can put your function of x back in later and then not have to change the bounds. But I wouldn't write 0 and pi halves once I start to write this in terms of u, because it's really not correct. Okay, and if it helps, maybe I could have written this in blue for you. So all that stuff became the du. All right, what is the integral of e to the u? It's just e to the u. We don't need a plus c because we're doing a definite integral. And again, I'm going to say, all right, when x equals 0, then u equals sine 0. When x equals pi halves, then u equals sine pi halves. I'm getting it from that line right there. So, let's see, what is sine of 0? Oops. Sine of 0 and sine of pi halves. So I'm integrating from 0 to 1. Those are my new bounds. You see how simple this is? Alright, so that's e to the b minus e to the a, or e to the first minus 1. And I will leave it to you to check the actual integral on the calculator, or whichever way you want to. Okay, now this should look familiar in that it has an inverse trig function, and we discussed in one of the other videos that you do not have formulas. You should have a formula sheet in front of you. You don't have formulas for inverse trig functions, so that is going to force arcsine to be our u. Again, that's just this right here is the arcsine of x. So eventually that's going to be replaced with a u. Now let's see how everything else falls into place. Du is the derivative of arcsine, so have your table of derivatives in front of you. I'm going to write it. Don't forget your dx. Now observe that this whole thing is present in the problem. Dx, which has an understood 1 in front of it, all over 1 over the square root of x squared. So green and blue, that whole integral just becomes, there's your, I guess I'll keep the colors, that becomes your u, and the rest of that becomes your du. And again, your bounds are going to change. Okay, what are they going to change to? Well, arcsine 0 and then arcsine of a half. Arcsine 0, now if you remember with arcsine, we only concern ourselves with this much of the sine function. It has to be 1 to 1 to have an inverse. So arcsine of 0 is 0. And then for arcsine of 1/2, you want to think of that as opposite over hypotenuse, opposite over hypotenuse. So arcsine is what angle has 1/2 as its sine. That's going to be your 30-degree angle, or pi 6. I always give them in radians. So when I integrate u, I get u squared over 2, or 1/2 u squared. I'm integrating from 0 to pi 6. Again, you did have an option to now put this back in for u, and then use 0 and 1/2. So that's completely up to you. So now what do I want? Pi 6 squared over 2 minus 0 squared over 2. So that part, the second part's going to go away. Pi 6 squared is pi squared over 36. So my final answer is pi squared over 72, because that 36 has to be multiplied by 2. And again, you can check that whichever way you like.